Now that we have reviewed completing the square, we're able to find max and min. We want to look at solving some applications. So here we're going to be looking at some maximum minimum problems. So sometimes you're given a graph. So this question says, find the maximum height and when it occurs. So that would be the time it occurs. So we have a graph here, which is measuring the height of an object in time in seconds. We have time on the x-axis and we have height on the y-axis. So the maximum height is approximately here. So we are able to read off the graph the height, which is 120. Oops, that doesn't go first. The height is 120 meters. That is the maximum height, and the time that it occurs is 5 seconds. So this point here, when x is 5, y is 120, is representing the time that the maximum occurs at and the height that is the maximum height. So if we have a graph, it's pretty easy to find the answer. Here we have an example of perhaps we're looking for maximum profit. So you'll notice that we always see the word either maximum or minimum, indicating what part of the graph we are looking to describe. So what's maximum profit and the price you need to sell. So you'll see price is on the x-axis, profit is on the y-axis. The vertex is given as 12,500. So the price is the first component because it is the x value is the price. So the price is $35. And then the y component, this is my y-axis, is profit, which is the second coordinate. So the profit is 12,500. So that's my maximum profit at the price of $35. So sometimes we're not given a graph, we're given an equation. So we are going to look at a maximum height problem. So usually it's a projectile that is going up and coming back down. So we have been given an equation and it wants us to find maximum height, the time that maximum height occurs, and the height at 1 second. So we are given the equation as height is given in vertex form. All right, so remember vertex form is the stretch. You've got your horizontal shift to the right or left, and you've got your vertical shift up and down. So HK is the vertex. So in this case, the vertex is 3 and 44.1. So what does each number represent? Well, the first number is the x, or in this case t, which is time. And the second number, k, is the height. So the maximum height is 44.1 meters, which occurs at a time of 3 seconds. So if it's already in vertex form, it's pretty easy to answer that question. So A wants the height, B wants the time. And then it says find the height at 1 second. So we want to know the height when the time is 1. So we are going to replace time with 1 second. So we'll put that in brackets here. 1 minus 3 squared. And then we'll calculate that height. So order of operations says do the bracket first and the exponent. So 1 minus 3 is negative 2. Then we're going to do negative 2 squared. So when you put that in your calculator, don't forget to put brackets around it because it's negative 2 times negative 2, which is positive 4. Then we'll do multiplication before addition. So we'll multiply negative 4.9 times 4, which is negative 19.6. And then finally we will add 44.1. And that gives us an answer of 24.5 meters, which is the height at 1 second. So if you have the equation, and especially if it's in vertex form, it's pretty easy to find the answers of maximum height at the time it occurs. Okay, in this question, another height question. This time we have a bullet that is going up and coming back down. We're given the equation, but this time the equation is not given in vertex form. So we need to change it to vertex form, and we know how to do that by completing the square. So we want to complete the square to put it in vertex form. So because it has a coefficient, I'm going to factor out the coefficient of -5 out of both terms. Oh, that's a t. So 100 divided by -5 is -20. Then we're going to figure out the number that makes that perfect square. So we're going to take 20 and divide by 2 and then square it. So 20 divided by 2 is 10, and then squared is 100. So we're going to add 100 to make that perfect square, and we're going to subtract 100 so that we don't change the value of the equation. Don't forget to multiply that back. So we want to factor this quadratic here. We know the factors will be the same. Half of 20 is 10. So we're going to have 2 of those. And then we're going to multiply the -5 by the -100, which is positive 500. And then we'll write it in vertex form. We have t minus 10 twice. And there we have it in vertex form. So, oops. So by putting it in vertex form, we can now answer question part A and part B. So part A says what is maximum height, and part B says what is the time, and the time it occurs. So maximum height is 500 meters. So that is here. The time it occurs is right here at 10 seconds. So the vertex tells us the time it hits its maximum height and the maximum height. You'll notice in B, it wants to know when the bullet hits the ground. So if you think of your quadratic, we've got this bullet coming up and down. We just found this maximum height by completing the square, putting it in vertex form. If you want to know where it hits the ground, you want to find these two values. And in this question, we want to solve, right? Solving means we find the x-intercept, which in this case would be where it hits the ground. So in order to do that, we're probably going to use the quadratic formula, or you could factor if that's possible. So I'm going to factor first, and then I'm going to use the quadratic formula, and we can see that we get the same results. So since we're solving, we want it to equal 0. So we think about height when it hits the ground. The height would be 0 when it hits the ground. First thing in factoring is always, is there a common factor? I see a common factor of not only -5, but also t. So that would leave me with t minus 20. And then once I have the two factors, I take each factor, I set it equal to 0, and then we solve. So this one we would need to divide by -5 to solve for t. So t would be 0. And this one we would have to add 20 to solve for t. So t would be 20. So it has a time of 0 at the beginning, and then it has a time of 20 when it hits the ground. And you'll notice that's also double the height. So the maximum height occurred at 10 seconds, and since it is symmetrical, right, the left side equals the right side, it takes 10 seconds to get to the top, 10 seconds to get to the bottom. You could also use the quadratic formula. If you don't want to factor, that's fine. So B is 100. A is -5. C is 0, right? There is no constant, so C is 0. And then we have 2 times -5. So we'll have -100 plus or minus 100 squared minus 0 over -10. We'll have -100 plus minus 100 over -10. So my two answers are -100 plus 100 divided by 10. Well, that's going to equal 0. And then we've got -100 minus 100 divided by -10. So that's -200 divided by -10 is 20. So you'll see that we get the same answer if we use the quadratic formula. Okay, so just keep in mind, if you see maximum height, you're completing the square to find the top. If you're trying to find when it hits the ground, you are solving, which means you're either factoring or using the quadratic formula. Okay, we also have similar types of questions with profit or revenue. So again, we're given an equation. This is given in factored form. So we are able to find our answers because we already have it in vertex form. So this question is giving revenue based on selling price. So here is my vertex, 40 and 16,120. What is that telling me? Well, the X is the price, or the sale price. So that's the selling price, $40. And the Y is representing the revenue. So the maximum revenue is 16,120. The price to achieve that maximum revenue is $40. And then it says determine the revenue if the sunglasses were sold for $50. So again, we have the revenue equation. We want to know when it's $50, so put in a price of 50. And then we'll just calculate that revenue. So 50 minus 40 is 10. 10 squared is 100. -10 times 100 is -1,000. And then that will give us revenue of 15,120. And then in this question, we are given another revenue question. It is representing the revenue produced by selling tickets on a plane. So the plane charges $200 a ticket, which is indicated here, and that is for 80 people. The price is going up, and the number of tickets is going down. So once you expand this, you're given the equation. So how many passengers will provide maximum revenue? So again, I see that word maximum. If we want to find maximum, we want to put it in vertex form, so we need to complete the square. So the first thing we'll want to do is factor out any coefficient. So we have a coefficient of -2. Remember, you only take that out of the first two terms. We ignore that last number. So we've got -2 factored out. So 40 divided by 2 is -20. Now I want to make that a perfect square trinomial. So I will take 20 divided by 2 and square it. That is 10 squared is 100. We subtract 100. And we still leave that 16,000 at the end. Okay, now we're going to factor this quadratic. So we know it's going to be the same, x minus 10 twice. We're going to multiply the negative 2 by the negative 100. Don't forget that part. And then we'll just tidy it up a little bit. We've got x minus 10 twice, and we've got 200 plus 16,000 is 16,200. So that tells us that the maximum revenue is $16,200. So what does this tell us, x minus 10? Well, x minus 10 is the number of times we're going to change the price. So if I set x minus 10 to 0, I get x equals 10. So what does that tell us? Well, the original price was $200 and the number of passengers was 80. That's where the 16,000 came from. The price was going up $1. Oh, sorry. The price was going down $2, and that would make another person buy a ticket. So we're going to do that 10 times. So $200 reduced by $1 10 times is reducing by $20, so $180. And we're going to put number of passengers up by $1 10 times. So that means 90 people are going to go on the plane. And then we're going to check 90 passengers times a ticket price of $180. Just going to check and see what that value is. And we get $16,200, which is our maximum revenue. So that should check with this number right here. That would be that number. So the x minus 10, 10 means we're changing the price 10 times. So it's going down by $2 10 times for a new price of $180, which means every time we drop the price, another passenger will buy a ticket. So it's going up by one passenger 10 times. So now 90 people are going to go, and our maximum revenue is $16,200.